And then we move on to something which, in different scale view, that is the levels of measurement. Right? Before we have same level, that's quantitative and qualitative level. Qualitative type of data, and inside or below the quantitative, there are maybe either discrete or continuous data. Right? But the level of measurement separates the data vertically into 4 levels. The first level is nominal data. Right, the nominal data is the first level that the data are categories, names, or labels which cannot be arranged. Such things, for instance, like social security number, or driver's license plate, or license plate on a car, on a vehicle, or political party. Or any passwords. All of them, right, are just number or labels or names that cannot be arranged. Like you cannot say one person's social security number is better than another person's social security number, or but basically you are able to arrange, but will be meaningless in some case. Right? You are able to arrange them following some rule. Right? Like we are able to arrange people's last name from A to Z, but it doesn't mean that the one going more in front is better than the one going after. Right? Before and after doesn't have any differences. So that means arranging is meaningless. Simply that was cannot be arranged means. The second level, which is called ordinal level, the data can be arranged in some order. Well, naturally it can be arranged in some order, but differences cannot be determined or is meaningless. Right? The difference are meaningless. For instance, the grades or the ranks. Right, naturally this type of data could be arranged and have some meaning. Doesn't like the number or people's name cannot be arranged or doesn't have meaning, but it could be arranged. But in this case, which ordinal is coming from? Well, it has order, right, from rank from 1 to 3 or grade from A, B, C, D. Right? But we cannot say that the difference is meaningful. Right? We cannot say that the difference are meaningful. Like, well, the difference between A and A minus is not same as the difference between a C and a C minus. Right? The difference between A and a B is not same as the difference between a D and a F. Right? Those things are, of course, A is bigger than B, A minus is worse than A, or D is better than F, and so on. Right? But for the difference, they don't mean same thing. Right? A and A minus is just meaning like perfect, maybe not perfect, very much excellent difference to excellent grade. But D and F is like the difference between passing grade and failing grade. Right? They are meaning different things. And for rank, right, the first place, second place, the difference between them is not same as the 49th place and the 50th place, right, the rank. So that difference between each rank or each order, right, each object, isn't that meaningful, right, or isn't that much able to be determined. You cannot say, well, what is the difference between the first and second place, or you cannot say what is the difference between 49th and 50th place. You cannot say what is the difference between A and A minus, what is the difference between D and F. There are differences. We can just say one is better than the other, but when we simply take the difference, that doesn't have any meaning. That doesn't have any meaning. The third data is called interval data. In this case, not only the order is making sense, but also the difference is making sense as well, right? But it doesn't have a natural zero, such as a year, such as temperature. Well, of course, this year is 1 year more than last year. 2020 is 1 year less than 2021. Going through as the time. 2000 is like 2000 years after the initial first entry, right? But the natural zero, right, is not meaningful. It is undefined, basically, right? The zero itself is defined, but it's not natural, right? It's not nature. Like the temperature is defined as under 1 atmosphere pressure, right? The water is completely become ice, is at 0 degree Celsius, and water is become steam, right? It's become boiling at 100 degrees Celsius. Of course, under different pressure, that's differently, but in 1 atmosphere pressure, that is that way defined, and that is how the 0 and 100 being defined. Then extend it or cuts that scale into 100, then extend it to make the degree Celsius temperature system. But also, right, the natural zero is not defined, even though the absolute zero, maybe you heard of it, right? Negative 273.16, so on, degree Celsius, right? It's called 0 Kelvin, but that is still the temperature that all the cells or all the species will stop moving. But that temperature is absolute zero that can be reached below still, of course. It's just that all the species is stop moving or not stop being alive, right? But that was still not the zero, right? It can be go lower. All the years, the zero is defined as Jesus was born, right? But after that, it started as the first century, second century, as what we're using in the nowadays. But still, maybe for some ancient group of people, right? They are not using that type of calendar to determine the number of years, right? It's still possible. So those things doesn't have natural zeros are called interval data. But basically, the order exists and the difference are meaningful, right? That's what the interval data are. Right. Finally, it's the ratio. Right, order exists, difference exists, the zero exists, hence therefore the ratio exists, right? That's why they call it the ratio data. And before was only the difference exists, that's only the data being called interval data, right? So the thing I didn't mention was, well, for the temperature, right? Today is maybe 10 degrees Celsius, tomorrow it will go to 20 degrees Celsius. You cannot say that tomorrow is 2 times warmer than today, right? It's just a number scale that can be tell the difference. That is 10 degrees more higher, 10 degrees higher, but it cannot say that, well, today or tomorrow will be twice warmer as today's, right? That ratio doesn't make sense since the natural zero does not exist. And for the ratio data, the order difference, the zero exists, therefore the ratio exists. For example, that a car's length, for example, a class time. Well, maybe in our regular hours of class sessions, that's 1 hour for each session. In summer or winter, maybe 3 hours for each session. That we can say, well, the class time in summer or winter will be 3 times than the regular classes, right? So that is the ratio type. Right, so 4 different levels. Nominal, ordinal, interval, and ratio. Right, that's 4 different types. That's 4 different levels, basically. Right, the next thing is called simple random sample. We're going through, right? The simple random sample is like how we get sample from the population. Well, one way is called random sampling, that we treated the individual as the individual in the population, right? Then each one is equally likely to be selected into the sample we have. And another thing is called a simple random sample, or simple random sample. That, well, we are not selecting one by one, we are selecting a group of n people, or n subjects. And subjects. Right, the simple random sample is that the original population will be separated into the sample of size n. That will be a lot. Well, a lot means something else. You can see that in a later chapter when we're talking about sampling distribution, you're able to see what that means a lot. But they will be separated into a size n, and the likelihood or the chance being selected of each of that sample of size n is equally likely. When a sample of size n subjects is selected in the way that every possible sample of the same size n has the same chance of being chosen. Right, so that is the most random thing we are able to find. Other things could be selected, like arrange the population, maybe every 10 we select one, then we skip another 9, then we select the next one, and so on. Or every 100 we select one, so every 10 we select one, and we skip the 9, then we select the next, we skip the 9, then we select next. Or something like to select sample is just by like doing a survey by just making phone calls of convenient thing, or so. Right, but simple random sample is what we're referring to in our course here, which when we are collecting data from the population using simple random sample, that is the most accurate way, basically. You will see later in when we talk about sampling distribution, that will be this sample has certain thing related to our population in a certain way. Right. So that is our chapter 1. So even though in our question maybe not written as simple random sample, but when we say sample, that means it is simple random sample. I'm always referring to that. Well, naturally, again, it's very hard or take a lot of work to make sure that the sample is simple random sample, but it is possible. And for our course, when we say simple random sample, that just means the majority of the work is done, simply. And what we do is just try to analyze or to see what happens to the data we already have, right? Then to do like whatever we want to do. Right, so that is our first chapter. In chapter 2, Chapter 2 is summarizing and graphing data. Right, so first section. The characteristics. First one is center. The center is the middle or average data value. What is the middle or average data value? That one obvious thing we can find out was what we can say is the average, the arithmetic mean, which is the sum of every data we have then divided by the total. The variation one measures how data value varies. It could be like in something we had obviously know was about the range. Right? The range was covering that the smallest to the largest, how long it is, how wide the data is. Two basically measures about the spread, right? How the data values vary or the spread of the data.